The floor is yours, Professor. Welcome. We start recording.
Okay. Assalamualaikum warahmatullahi wabarakatuh, honorable guests, distinguished guests, and all esteemed attendees. I feel very honored to be giving an insight in this event celebrating One Health Day. May our meeting today be filled with blessings, useful knowledge, and close friendship for all of us. Today, we will explore how an industrial engineering approach, specifically house of risk analysis, can provide a systematic framework for securing our food supply chains through an integrated One Health lens. Okay, this is my curriculum vitae. My name is Irwan Budiman from Industrial Engineering Department, Universitas Sumatera Utara from Indonesia. I'm Bachelor and Master of Engineering from Universitas of Sumatera Utara. My research area is green productivity, supply chain management, ergonomics, and human factors engineering. Maybe our guests more familiar with these ergonomic and human factors and strategic and risk management. My several publications regarding these topics of One Health Day, maybe halal risk identification in chicken slaughterhouses, case study in Medan City. This is published in a book chapter. And measurement of raw material inventory performance at halal frozen food business, developing small and medium enterprises performance assessment using SCORE model with halal consideration, measurement of halal manufacturing performance with SCORE model, identification of halal risk in resource production using house of risk method, and halal risk analysis in Indonesia slaughterhouses using the supply chain operation reference and house of risk. Maybe for today cases, I will use the slaughterhouse in chicken product. You can contact me over my email, irwanbudiman@usu.ac.id, or you can see my publication in Scopus, Clarivate, or Garuda, or ResearchGate. To guide our session, let me outline our journey. We will begin by understanding the context, the fragile food chain in One Health world. Why the food supply chain is so critical in One Health approach. We'll then examine the problem with conventional reactive risk management before returning to the solution offered by the House of Risk. We will take a deep dive into both of these phases. So in this session, I will try to describe HOR, House of Risk Phase 1 and House of Risk Phase 2. So we can examine it better. And then we will illustrate them with a real world case study from poultry supply chain and conclude it by discussing how it will strengthen the pillars of One Health. As we can see, the food supply chain, it contribute to so many aspects from production, food processing, transportation, wholesaler, until it comes to customer. In your opinion, maybe, how can House of Risk be utilized to support food safety? Maybe this is the first in mind, why we need House of Risk. And how can this House of Risk support food safety? Okay, we will go to the context. As our foundation, we recognize that One Health acknowledge the inseparable interconnection between human, animal, and environmental health. And at the heart of this relationship stands the food supply chain, the physical bridge that delivers products from farm to fork. When this chain is contaminated or fails, the impact is systemic, like when zoonotic disease outbreaks or antimicrobial resistance because of uh, the wrong use of drugs, and maybe like foodborne illness. This challenge demand not only a reactive but a proactive one and structured approach. That's why we need this house of risk. And I quote One Health Commission policy. There are three: connect, create, and educate. I really appreciate this three policy of One Health Commission. And for the critical junction, the food supply chain, we can see the how the animals or livestock will impact to environment by their waste, by their feed, and the environment will give the feed to the animals of livestock. And both animals and environment will give products to human for consumption. Just we can see like the picture on the right side, left side. The vulnerability of failure at any point in this chain, for example, contamination at the farm can trigger a cascade of effects impacting like human health, like foodborne illness, especially Salmonella, E. coli, or animal health like zoonotic disease outbreaks, avian influenza, or environmental health because of antibiotic resistance or pesticide runoff. And the question is, how can we systematically manage this interconnected risks? This is the big question we need to explore in this house of risks. And the problem will be usually the problem is the limitation of reactive approach. The traditional approach are often reactive. We wait for a product recall or an outbreak to occur before we respond. Like we can see, like Toyota airbag, as we can see, or others where there's outbreak over there. We just do the reactive side of management. So it's like fighting fires instead of preventing sparks. Furthermore, we frequently operate in silos. Veterinarian focus on animal health, like public health official on human, and then environmental agencies on pollution. The result will be critical vulnerabilities at the intersection of these sectors. Amis. Our system is only as strong as its weakest unmanaged link, because usually every services only focus on their part. So this is the why traditional risk management falls short. And the solution, maybe from my side, I can introduce to house of risk. This house of risk, what is actually the house of risk? It comes as a powerful solution in the industrial engineering world. It is a proactive risk management model derived from quality function deployment. As we can see in the right side, the picture is the quality function of deployment. I will, this is the previous form of the house of risk. What makes this is what makes house of risk powerful, because it is structured, quantitative, and prioritization focused framework. Simply put, house of risk consists of two phases. Phase one focus on identifies and ranks the biggest risk, and the phase two selects the most effective preventive action. These two phases work like building a house, a robust foundation, and a structure. So this previously derived before house of risk is called quality function deployment. After the merger between quality function and deployment with Lean Six Sigma, it turns out to be a new model, which is called house of risk. Maybe I will describe a little about quality function deployment. The first step is voice of customer, and then technical specification, and then we calculate the relationship matrix, and then the fourth step is correlation matrix between the technical specification. The fifth one, there's two sides. The first side is customer importance, and in the right side there's competitiveness between uh, we call several suppliers. So this is from KFD, previously visualized house of risk. And in the next step is technical assessment and target. But wait for a minute, we don't need to follow this KFD form, but for the house of risk, maybe almost the same. We will see it later. The two phase of house of risk structure. The phase one, house of risk one, focus on the question, what are our biggest risks? Then the process of the house of risk one is identifies risk events and their root causes, risk agents, and then prioritize them. In the phase two, house of risk two, they focus on what are the best actions to prevent the risk agent to happen. So the process is identifies mitigation action and selects the most effective ones based on their ability to handle the top priority risks. So maybe some of you will ask, do we need the two phase to be uh, did in the uh, research? The answer is no. You can just use phase one in your research. No need until phase two. Let's deep dive to phase one, house of risk one. The goal is to answer fundamental question: what are our biggest risks? It does this through four systematic steps. We identify what are our biggest risks. It does this through four systematic steps. First, we identify risk events. And then the example, customers exposed to salmonella from contaminated chicken meat, for example. And then the second one is identify risk agents. The risk agent is the root cause that trigger the risk event happened. For example, poor biosecurity in farms, like inconsistent chilling during process, because inconsistent chilling during processing. And the third is assess severity and occurrence. Severity is impact of the risk event. We can use a Likert scale 1 to 5 or 1 to 9. It is based on researcher judgment. Occurrence also the same. We can use occurrence is the probability of the risk event happening. We can use the Likert scale 1 to 5 or 1 to 9. It is based on your judgment also. And then the fourth is calculate aggregate risk potential, or ARP. The formula is severity multiplied with occurrence. This number quantifies the criticality of each risk agent, and the output is a prioritized list of risk agents from the highest to the lowest ARP. So from this house of risk step one, maybe I will try to do it visually like this. This is the house of risk phase one, looks like. The left wall lists the risk events, and the ceiling lists the risk agents. The main room in the middle is the correlation matrix between risk event and risk agents. So, and then on the right wall, we have the severity ratings. And in the foundation, there are occurrence and also ERP, which calculated from occurrence, severity, and correlation metrics. I will uh, describe it one by one later. So this matrix structure actually allows us to visually see cause and effect relationship between the risk event and risk agent, and how we make decision based on this quantitative calculation, not just by our instinct. So this is a quantitative prioritizing. For ARP, we can use the formula occurrence multiply with sum of the severity multiplied with correlation between risk agent and risk event. I will describe it later in the case study. And next, we bring this theory to the real world case. Imagine that we are risk managers for a poultry company committed to One Health principles. Our goal is to proactively reduce the risk of microbial contamination like Salmonella or E. coli in a farm-to-fork supply chain. We will analyze 4 critical stages from the farm level, like breeding, hatching, growing, the processing plant like slaughter, evisceration, sealing, distribution like transportation, storage, or in the retail process like storage, handling, etc. And then this is the case study. If we just simplify it, we can use this table just to simplify it. But after we conducting the House of Risk phase 1 process, these are our results. We need to notice how the use of contaminated feed or water at the farm emerged as the #1 risk with the highest ARP of 20, the rank 1, 20. The key insight here is that the highest risk originate at the earliest stages, because it means in the farm stage and the transport stage. So this is a crucial finding that we might be missed if we only focus on an end product inspection. So this is one of the what we call collaboration from one step to another step, from one supply one chain to another chain. If we focus on only to end product inspection, we won't get this result. It aligns perfectly with One Health philosophy. Intervention at the source is the most effective. So another one, if I change these tables to a more visually like quality function deployment, we can use like this picture. The left side is the risk event. The upper side is risk agent in the ceiling, and the right side is severity, and in the middle is the relationship matrix. And if we want to calculate, for example, ARP for poor equipment, we can calculate it by 3 multiply with 1 multiply with 2 plus 9 multiply with 3, and we found the result is 87. We can see from the picture. Okay, maybe next. Now, after we know our biggest enemies, which is risk agents, the time for the next phase, which is phase 2. House of Risk phase 2 will answer what are the most effective preventive action. We start by proposing various mitigation actions. We then will build a correlation matrix to assess how strongly each other action will giving or address different risk agents. Next, we calculate the total effectiveness. And by summing the ERP of each related risk agent multiplied by its correlation value, this gives us the benefit per cost of each action. And then the last is consider the cost and difficulty. to make a final and feasible selection of action based on maybe financial cost, time to implement, manpower required, or technical difficulty. For example, for HOR 2, we select mitigation action. For example, the mitigation action implement a mandatory water or feed quality monitoring and certification program. It target the risk agent of contaminated feed water from the house of risk phase 1. So we will score the mitigation action 9, and the 20 it comes from the ARP from the house of risk phase 1. So if I want to detail it in visually in KFD like structure, it will be like this. The risk agent, the prioritized one from house of risk phase 1 will plot here, will be plot here in this risk agent. Only the prioritized one from house of risk 1. And then we develop mitigation action based on these risk agents. So this in the ceiling, this is mitigation action comes from risk agent. And then in the right side, there's ARP comes from house of risk phase 1, previously house of risk phase 1. And then in the below, in the foundation, there's total effectiveness. It comes from calculation, like we can see in the right side. And then the cost of or difficulty, we calculate it based on like cost, like financial cost, time to implement, manpower required, or technical difficulty. So and ETC ratio is total effectiveness divided with cost of the difficulty. So how we prioritize house of risk phase 2, we prioritize it based on highest ETC ratio. Like this, we can see the standardized on farm feed storage have the highest ETC ratio with 270. We will prioritize this mitigation action. For example, like this. And then what is the differences between house of risk phase 1 and house of risk phase 2? For feature of purpose, house of risk 1 identify and prioritize risk agent and risk events. Meanwhile, house of risk phase 2 prioritize and select the most effective mitigation strategies for the high priority risk agents identified in the house of risk phase 1. And for the process, in house of risk 1 involves identifying risk events and risk agents, then calculating the aggregate risk potential for each risk agent. And in house of risk 2, it involves evaluating the effectiveness of potential mitigation action against the prioritized risk agents. And the outcome in HOR 1, a ranked list of risk agents based on their ARP results. In house of risk 2, a set of prioritized mitigation strategies to reduce the occurrence of prioritized risk agent based on their ETC. Okay, and how we connect between the HOR and the One Health in an action like water quality monitoring will directly protect the environment and improve animal health. By reducing this exposure to contaminants, we can get a better farming practice, reduce the need for antibiotics, we can combating antimicrobial resistance, and finally, all this action will contribute to human health. Through a safer food products, the House of Reeds will provides the technical framework that translate the One Health philosophy into measurable, prioritize, and actionable steps. Like this One Health mitigation action, as we can see from animal health, environment health, and for the human health in the end. And for the conclusion, HOR as a strategic tool for One Health, there are three key messages. First, HOR shift our paradigm from reactive to proactive. Prevention is always a better and cheaper than we cure after the problem happened. The second, it provide data-driven prioritization, ensuring resources target the most significant risks and effective solutions. And the third and the most important, HOR is a system thinking tool for One Health, making a collaborative, integrated approach actionable and measurable. This is a call to action for policymakers, industry leaders, and also us as a researcher. Maybe if there's a discussion, we can use this mini discussion uh, segment to discuss. Okay, maybe there's the one last thing. One Health recognize the connection, the house of risk, or, or provides the map to navigate it. By fortifying a single link in the food chain, we strengthen the health for all. Thank you very much for your attention, and thank you.
Thank you, Dr. Irwan, for your amazing and informative presentation. That was literally nice. It's not an easy thing to understand house of risk analysis, as well as the mitigation strategies and how we can implement One Health approach to prioritize the risks which are related to mitigation strategies. For me, it was literally amazing and I literally enjoyed it. Thank you so much, Professor. Now I will
Thank you.
stop recording. Thank you.